So when we talk about quadratic inequalities, now you remember from grade 10, an inequality means I use the following. It's going to be smaller than, bigger than, smaller than and equals to, and bigger than and equals to. But now I'm going to teach you how to represent them graphically. So I'm going to be using a few examples for it. So let's say I'm given x squared minus 9 must be bigger than 0. So when we have a question like this, we first do the following. We first find something that is known as our critical values. So if we use CR, or you can use critical values. Now what does this mean? We are basically going to be saying we put it in a bubble because it does not actually count for marks, but we will be saying that x squared minus 9 is actually equals to 0. So if we factorize it, what do we have? We have x minus 3 and x plus 3. So therefore, it is x equals to 3 or x equals to negative 3. Now from here, we can represent it graphically. What is meant by representing it graphically? We can draw it. Anything that is x squares plus minus something, what type of shape is it? What type of graph is it? It's a parabola. So if I have to show it on a parabola, what do I know? My x-intercepts are at 3 and negative 3. And what type of shape is this? It is positive. So therefore it will be smiling, it will be happy. So basically what they want to know, where is this graph bigger than 0? So where will that happen? It will happen from here going upwards and from here going upwards. So how will we represent it? We will represent it by saying, but it is where x is smaller than negative 3 and where x is bigger than negative 3. So we are basically saying that from this point going up, it will be larger than 0. And from this point going up, it is also larger than 0. Remember, on a plane, Cartesian plane, where the two intersect, it's usually 0. Okay, I am going to be giving you more examples. Yes. This one's the one that you have to get for marks. You have to use this one. This one's supposed to be positive 3. Positive 3. So it's larger than positive 3. So all values from this point going onwards is going to be larger than 0. And all values from this point going onwards, it's smaller or larger than 0. Now, if I have another example where x squared minus 9 is smaller than and equals to 0. Once again, we're going to make our bubble. To get my critical values. And this will be x minus 3. I'm getting ahead of myself. X squared minus 9 is equals to 0. So what do I know? x is -3 and x plus 3. So my critical values are where x equals to 3 or x equals to -3. So now we have to represent it graphically. In order to be represented graphically, I have to draw it. This is usually where you get your marks. It's for the sketch or for the method and for your answers. Now, we know it's going to happen at -3 and at 3. This graph is positive or negative? Positive. So it will lie there. Now, we look at what they ask us. They say, but it must be smaller than and equals to 0. So where is it equals to 0? On a standard Cartesian plane, it will be exactly there. That's where it's equals to 0. Where is it smaller than 0? It's here at the bottom, this area below the line. So where is it smaller than 0? Between which values? It's between -3 and 3. So my answer, I will also say that x is smaller than 0 at or between -3 and 3. Now, why is it also equals to? Because they asked where it's also equals to 0. It's equals to 0 at exactly this point and this point. So we have to include those values. I'm going to add another example. So, what if I am given the following? X squared, let's go, -x squared plus 4 is smaller than x plus 2. What's the first rule with any inequality or equation? I have to get everything on one side. So the easiest would be to avoid having to use the rule. Now, what's the rule? If I divide by any negative value, my crocodiles, or smaller than and equals to, will change places. So if I divide by a negative, if it's a smaller than, it will become a larger. So they basically just swap over. So in my case, for simplicity's sake, I will try to get this side equals to 0. If I take x squared over, it becomes positive x squared. Then I have plus x. If I take plus 4 over, it becomes -4. So I've got -2. So now again, critical values. We say, but it's equals to 0. Okay. So what will be my factors if I start factorizing it? My brackets will be x plus 2 and x minus 1. So what does this mean? It will be where x is equals to -2 and where x is equals to positive 1. Because it's negative in the bracket, it becomes positive. Now I have to sketch this. I draw my Cartesian plane. I know there in the middle it's 0. So where does it lie? Around about there is -2, around about there is 1. It does not have to be up to scale. We just have to get the idea of where the shape lies. Now, we have to refer back to what they are asking us. Where is it? Bigger than 0. Above it. So, from this point going upwards, So therefore, what will be my final answer? It will be where x is, okay, larger than which value? Must be larger than 1, and x will be smaller than -2. Okay. Let's find you another one. Mm-hmm. Okay, so as Professor mentioned, you can write it differently. So you can either write it in inequality notation, which is what I do here, or we can write it in interval notation. So if I have to write this as interval notation, I'm going to be doing this in, let's go for it. So interval notation, then I say the following. X is an element of, now I just have to see exactly where it lies from -infinity up until, so what's my lower limit in this case? It is -2. So -2. A round bracket. Reason being, if I use interval notation, if it's a block bracket, I say it's also equals to that value. If it's a round bracket, it is not equals to that value. But is that the only limitation here or parameter here? No. So we use a U to signify and. Now that and, it lies between 1 and positive infinity. So if I have to do the previous two questions also in this notation, so if I have this, for example, it lies where it is smaller than -3. So I say x is an element of -infinity and -3, and it also lies between 3 and infinity. If I have to use this example, x is an element of, and it lies between -3 and 3. Okay. Another example of where you have to do it graphically. Let's go for that one as well. So I'm searching for a little bit more of a difficult one. Let's go for x squared minus 2x minus 15 is smaller than and equals to x plus 3. What's the first thing I should do? Get everything to one side. So this x comes over, it becomes, or I subtract both sides by x, it's -3x. And I also subtract both sides by 3, or the 3 comes over, it becomes negative 18. Now I have to factorize this. What will be my brackets? So keep in mind, what are we doing here? We are just getting our critical values. What will be my two brackets? Will be negative 6 plus 3. Okay, so therefore this all lies between where x is 6 and x is 3. What 3 specifically? Negative. Now once again we have to represent it graphically. If I represent it graphically, it lies where x is 6 and negative 3. Now what are we looking for? We are looking for where it is. We're looking for where it is smaller than 0. So where will this graph be smaller than and equals to 0? It is smaller and equals to 0 for that part. Does it include those two values? Does it include this point here and this point here? Why? Because they say it's equals to. So what do we have to, how do we denote it? We say but x is larger than and equals to negative 3. And it is smaller than and equals to 6. If I want to use interval notation, I say but x is an element of negative 3 and 6. Great.